Okay, thank you everyone. Welcome to this session. Really appreciated taking your time out in the afternoon and after the lunch. So thanks a lot again. My name is Samir Naik. I am the Senior Product Manager at VMware in the Edge Business Unit. Joining with me on the talk today is Kyle Allen from Airspan. He's the VP Sales Engineering, primarily focusing on the RAN product lines from Airspan Networks. And he's our RAN partner for VMware. Thank you. Hope everyone's having a great VMware Explore, the second day. Lots of exciting news yesterday from the keynote sessions around VMware as a whole, and from our CEO, Raghu, as well as from our GM, Sanjay Uppal. And one of the announcements around that was the initial availability of private mobile networks and our partnerships with 3 managed service providers, and we can bring that solution to the enterprise and customers of different verticals. So happy to see that coming to the day of light here. It's been a long time what we have been working on, and our collaborations with Airspan and other partners as well. So thank you. With that, let me get to the slide. Okay. I'll leave the disclaimer for a few seconds as mandated. A quick agenda. We all talk about enterprise, right? We talk about enterprise connectivity, so that's the key message, and how private networks is one of the key things which we want to the enterprise, and that's the reason for bringing this enterprise-centric private mobile networks from VMware. We'll talk about the PMN components, the architecture, and the orchestrator, and then we'll leave some point for Q&A. So just to give an idea of how things have evolved, what we want to do is that a little deep dive from our yesterday's session, talk into how we are bringing in the VMware edge computing along with our legacy in orchestration in the infrastructure and the overlay, combined with the RAN, what has been provided by Airspan and their innovation in their private network space. So that's the value proposition which we bring to the private networks, and the ease of deployment of that private network in these enterprises. How we want to remove that complexity and the areas where there are some fringe thoughts about why and how to adopt that private networks. That's our key goal here. Okay. We talked about modern edges, right? I mean, there are edges evolving. Edges now defined very well at the enterprise. Edges in different industry verticals. We looked at automobiles, we look at manufacturing, factory automations. Everywhere there is a deep desire to do this digital transformation. Somewhere already are on the journey of adoption, and there are some key considerations everyone into looking at. So we want to have an ultra-reliable, SLA-driven. All of these are new use cases which require high mobility, better coverage, and a well-secure and software-defined. There has been some monolithic hardwares. Now we want to go to the next infrastructure towards a software-defined network. And at the same time, some computing resources so that we can manage low latency and high bandwidth requirements as well. So that's been driving factor across the different verticals in the enterprise which we have talked to. As we know that, I mean, there are already existing technologies. We all know about traditional LAN, the wired networks. Wired options there are Wi-Fi options. Hey, it works for me. What's new? What is it? But obviously, the trend is that there are desire for better applications, better efficiency, productivity. There has been some LAN which can suffice in internet access, wireless, Wi-Fi, limited number of users. We come to that topic as well. And then the communications which interact with it. You see the dome and limited in terms of how many users we can go. But as we expand, there are devices which are now becoming much more mobile, very latency sensitive, within the enterprise premises, indoor, outdoor, and that ability to complement that technology, it's going to be complementing an existing Wi-Fi technology with the private mobile networks. So that's the desire and the need, and these emerging use cases are driving this very much in that direction. Obviously, dedicated critical applications is a very prime importance. Security and control is becoming very important for when we deploy private networks. So that's some of the areas we want to ensure that we can make it happen from a private mobile network as a solution offering. Okay. So I want to briefly touch upon what are the current existing technologies and how we can drive a private mobile network. Obviously, you can say, okay, I can go into a public network, get a slice of a macro network, and provide a private network for my enterprise within this prem. If you look at the top, so if you have a given spectrum, the consumers will take bulk of the chunk for the private networks, which is on the public domain. And only a few slice of that network gets dedicated to the enterprise. So you're not utilizing the full bandwidth. You're not able to utilize what can be categorized for a slice for a high bandwidth or a low latency. You are always relying on that macro service and a part of that spectrum for that delivery of that model. If you look at Wi-Fi, yes, you can do Wi-Fi. It's a subset of things, as we talked about. They will be all competing for the resources. There is no mechanism of guaranteeing service, throughput, latency. It's all devices are treated equal in that Wi-Fi space. And if you want to derive a drone or AGV, which is guaranteed services, it becomes a problem. So we look at private mobile networks, which is very dedicated spectrum, all utilized by the enterprise users, devices within your network. And you see different lanes so that you can categorize even those users which are of very high SLA, which are requiring high QoS, something which is of critical importance in your manufacturing plant, automotive. That's very critical. You have the highest bandwidth, and the lowest latency. You assign that devices to that, or you assign that users in terms of security applications. So that's the private mobile network, which the trend's moving around. And as we know, there are several opportunities in terms of spectrum being relaxed and been provided by the government. US has a CBRS spectrum, which has been assigned unlicensed band, as well as some semi-licensed band. European operators been given, and enterprises have been given license specific spectrums called the N77 and N78, especially in Western Europe. So that takes away one of the major hurdles of a dedicated spectrum for these deployments in private networks. Okay. So obviously the question is, what is required for me to build a private networks? Obviously it's very similar to a macro, but it is in a components which is condensed to what is for a private network in an enterprise. There are 5 pillars in comparison of what we need to deploy. RAN, obviously, is the radio access network, very akin to a Wi-Fi access point in terms of form factor. Connectivity is the spectrum we just talked about, which connects that access point to the devices. And then there is the core called the private converged core, which supports both the 4G and 5G technologies. It processes the data of the devices and connects the devices to the internet in the backend. And obviously, the devices are the endpoints. The endpoints has been changed more from consumer to all of the devices, which we know of from IoT devices, from 4G, 5G cameras, enabled cameras, and other devices you use in manufacturing plants as well, which are 4G and 5G capable. And to interconnect all these devices together, you need a management and an orchestration for all these devices, along with the network together. And that's where we bring in the cloud orchestration to tie all these pieces together and give a holistic, single pane of glass visibility to these private networks. And this is common across whatever way you deploy a private network. So this is part of the components. Okay? So we'll touch a little deeper into each of these components and how we are enabling all of these components in such a way that it's much more easy to deploy and manage at the same time across multiple enterprises. I think I'll hand it over to you.
Sure.
On the next slide.
Thank you. Yeah, so I'm Kyle. I'm from Airspan Networks, and we focus solely on small cell radio access networks and have done that for many years, and are really excited to kind of break new ground with VMware and how we take what's traditionally been an operator technology into the enterprise. I'm going to give you a 5-10 minute whirlwind through radio access networks. So first of all, from an Airspan perspective, we've been around quite a while. We sell to major mobile operators, and we sell small cells. So not those cells that you see on the large towers, those radios, but smaller radios that go indoors to supplement those macro radios. And about 2 years ago, as private networks became, people started to think about what's a private network, it quickly became obvious to us that same radio access technology was very applicable to enterprise. So now we've expanded our partnership with VMware and others in the enterprise space to take that same radio technology carriers like AT&T and Verizon are using and take it into the enterprise space. So our radio access network, right? What are some of the principles that we built it on that differentiate us? One, we believe in an open architecture. What that means for us is we work with anybody's core. So some of the traditional telecom providers like an Ericsson or a Nokia are selling you, wanting to sell an end-to-end, right? Their radio, their everything, all the way down to the end. What we've decided to do is focus solely on the radio. And so whoever's core you want to use, in this case is VMware's distributed core architecture, works with our radio. We have carrier class software. That means that our software was developed with the operators. So we have a full feature set there already ready to go. This is important because one of the things as private networks mature that you'll be able to do is to add mobile operator coverage. You could take your private network and you could also layer on a network that lets your AT&T or your T-Mobile or Verizon handset work at the same time on the same network that you deployed. And to do that, you have to have their full feature set so that it's a seamless experience. And then one of the differences between Wi-Fi, and Samir hinted at this, explained this in kind of his chart very well, is it's deterministic. So 4G and 5G technologies are deterministic, and that's because they're synchronized, right? So unlike Wi-Fi, which is asynchronous, these are very tightly coupled across the radios and across the service layers. So what does that mean? It means you have predictable latency, number one. And that latency doesn't get worse the more and more people you put on the network because that packet is leaving at a certain time. And all of those radios are synchronized, which allows for seamless mobility because they're all on the exact same clock, they all know what each other is doing, and they're all coordinated. So that deterministic piece makes it a perfect kind of augment to Wi-Fi. So you have all your traffic on Wi-Fi, and then you have certain applications that you may want to separate off because to a network where you absolutely know the latency that you're going to get and you have a predictable experience there. Also, not to get too deeply in the weeds, but our radio is built on a modular technology. So if you know the emerging 5G RAN architectures, it's basically the lower three layers of the protocol stack. They've given these acronyms, RU, DU, CU. But what we've done is take those in a containerized software and put them all on a piece of hardware together, which is a little different than some of the other operators. What that does is it gives us flexibility in the future to take pieces of that off the hardware and run it on edge compute. Right now, we think the simplest and easiest way to deploy is to put it all on one box. But we want to also have software that's flexible for the future so that we can begin to take pieces off for various applications. And then finally, we united all together with a control platform called the Airspan control platform. And what that does is coordinate all the radios. In the US, it coordinates the connection with the CBRS network, which I'll talk about here in a second. And then it also provides a rich API suite that can be accessible to VMware's orchestrator so that they can take the whole thing and make it easy to use end to end. It's a fuzzy one. So what's a radio look like, right? We have both 4G and 5G radios. As exciting as it is to read a specification to you, I just want to show this. We have indoor and outdoor. The indoor looks a lot like a Wi-Fi access point would. The outdoor, is not very big. It's like this big, can be mounted on a pole. Outdoors, they're both in the CBRS band, which is labeled band 48 by 3GPP. And then typical ways you would power an indoor or an outdoor unit, right? Power over Ethernet, or an AC to DC adapter for the indoor, and then the DC power input for the outdoor. And it's important to say with LTE, which is the 4G technology, your channel bandwidth is 20 megahertz per channel. So this radio can do 2 channels and aggregate them together, so you can activate a total of 40 megahertz. And that 40 megahertz is what gives you your throughputs. So you can get a little over 300 megabits per second from a 4G node. The nice thing about 4G is it's quite mature. And there's a wide device ecosystem for 4G. So it's a good place to start. From a coverage scenario, an indoor unit can cover a little more than Wi-Fi, right, depending on the environment. So you can get 10,000 square feet, 15,000 square feet. In like a big box store or warehouse where it's mounted on a high ceiling and there's no obstructions, you can even get 20,000, 30,000 square feet from an indoor radio. On an outdoor radio, you can actually, depending on how high you mount it up, get quite a range out of it. We can do up to 8 kilometers away, depending on the environment on an outdoor radio. And then we augment that with our 5G radios, which I didn't even put the pictures here, but they look exactly the same. You wouldn't be able to tell any different. The power levels are regulated by the FCC and CBRS, so they're going to be the same. The difference is you can now, instead of two 20 megahertz channels, you can go up to 100 megahertz channel, which then gives you almost 900 megabits per second of throughput per radio. So you can get a lot more bandwidth out of 5G, and it also opens up some of the more advanced 5G features, which I won't go into, but you can actually customize slices and service layers for different applications as the technology matures. I mentioned this CBRS a few times. I don't know how familiar everybody is with that. That is the US version of shared spectrum. So the FCC made 150 megahertz of spectrum available. It's from 3.5 to 3.7 gigahertz. And that is available for anyone's use, which is a complete change in approach, right? All of the other spectrum available to mobile operators is purchased by a mobile operator, for billions of dollars. The FCC made this piece available for anybody to use, and it comes in three tiers. The bottom tier, anybody can request that. It's called GAA, typically General Authorized Access. And on that tier, you connect to your network. That network then connects to this central system, this Spectrum Access Database, and that's run primarily by two organizations, Integrated Wireless, another one is Google. And it asks for spectrum. It says, hey, I'm in this region. I need 20 megahertz, 40 megahertz, 60 megahertz of spectrum. It coordinates, sees who's around you, and then assigns that to you, right? And it's yours to use. Then you have a priority 2, and it's called a PAL, a priority access license. This, if an organization wants to purchase a specific, reserve a piece of the spectrum for themselves in a certain location, there was an auction. So the subset of this 150 megahertz was made available for you to purchase so that you know you have it whenever you want. Now, if you're using it, it turns into GAA and anybody can use it. But you know that when you work in that place, you're going to get that piece of spectrum because you paid for it effectively to the FCC. And then the top one are the incumbents, primarily Department of Defense. And the FCC wanted to be completely sure that they protected all those legacy technologies, and so it manages that as well. If one of those type of were to come into range, it reassigns the spectrum in a way where there's no interference with those. But the power of this is that you can now take 4G or 5G technology and you have spectrum to operate it without having to go to CC auction and try to purchase it for yourself. So a little bit more about the devices. The new thing compared to Wi-Fi that you're not used to, but you're probably used to from your phone, is a SIM card, right? So the SIM card, you're used to those physical SIM cards. You just swap in and out to change carriers, right? Or now there's eSIMs where you can just do it electronically, but that is new. That's different than Wi-Fi, right? So for enterprise, that's new. And that needs to be provisioned on the core, and what that does is allow that seamless authentication between all of the access points. So you never have to search for an SSID, you don't have to enter in a password. All of that stuff happens automatically in the background. But it does add some complexity, which means we need people like VMware to come in and simplify it all. If AT&T is doing it, they do it once for everybody. When you as an enterprise, you don't want to have to manage all the details of provisioning those SIMs, and so this orchestration does it for you. And then you have the end user devices. You know, your handset's the most familiar one, but there's a lot of CPEs, there's cameras, more and more different devices are coming out that can utilize this kind of really targeted at the enterprise space. And then you have your radio, right? And the radio is what connects it all together and does the RF layer. So those are the pieces, and then I think next, Sameer's gonna piece it all together for you.
Sure. Thank you. Thanks a lot.
Not too bad.
Yeah, perfect. Yeah. Thanks for covering the RAN section, and I think we'll talk about tying this all together and how we can simplify and really remove that complexity. We everything and have it in mind, right? So, as we talked about VMware Private Mobile Network, enterprise first approach, and how do we deploy it, right? So, if we look at the deployment, so obviously it's the customer premise where the RAN is at the edge. Obviously it's the access system, and that's what the RAN on the left side is to the 4G and 5G, and connected to that is all your devices in the enterprise prem. And at the same place, we have the deployment of the packet core, which Kyle just mentioned about, which does connectivity to the outside world and connectivity to the RAN. And that component is hosted on the VMware Edge Compute Stack. You might have heard about this announcements as well. So this allows you to deploy any VM or container-based application on the same stack as any other edge native application. So if a customer or an enterprise is running any automotive or any other applications or retail applications in their enterprise prem, the same edge compute stack can run the packet core, which is both 4G and 5G capable, on that same edge compute stack itself. So you're not having equipment sprawl, you're managing a single piece of hardware for both your application as well as for the private mobile network. So that removes one of the additional barriers for adoption. From the edge, and at that premises, you have the control plane and the data plane of the private network packet core. The reason being is to ensure that your data does not leave your premises. We're expecting a lot of the data would be consumed within the enterprise prem. So it's more of an east-west traffic between devices or some of the hosted services within your enterprise itself. So control within your premises, data within securely stored in your location. It's all garden walk, right? On the hosted side, so we interconnect between this in a distributed fashion. The management plane and the orchestrator is hosted in our cloud environment. So it could be in our clouds or on the hosted cloud environment. What the management plan on the 4G and 5G core is connected through our SD-WAN link. It provides resiliency and guaranteed services from your core to the management plane. And all to tie it all together is the VMware developed private mobile network orchestrator. So it orchestrates the RAN, it orchestrates the packet core, and it manages from provisioning, deployment, and day-to-day operations completely through a single pane of glass from our orchestrator tool, which is built on top of our existing SD-WAN cloud orchestrator. So it's all built in. You go in and provision from day -1, day 0 to stand up of the site, stand up of your core, which is very centric to your site, stand up of the RAN, provision, and also for the subscribers. All managed through the single orchestrator tool. You don't go through, we abstract all the element management systems for the core or the RAN. This is one single pane. So what's the value prop here, right? What VMware bring to it? So as I talked about just the cloud, right? The unified central console for all management and orchestration of the different network components through a single pane of glass. It's multi-tenanted, so you can manage multiple enterprises, multiple sites through the same console. It's integrated into the same compute stack, what we have from the edge compute stack, the transport, the networking, all embedded what we have from our VMware portfolio of products, and provides the network intelligence on top, which is another service which we offer. It's very secure, so it's a security posture across from your LAN network to your private networks, as well as to our WAN network, which provides on our SD-WAN link. And it connects to your multi-cloud services as well, which could be hosted on your own data center or could be any other applications which is on our public clouds. So we provide the interconnect to that public cloud as well. Okay. And we talked about connectivity, which is the private mobile network. So all converged along with the leading RAN ecosystem of partners with Airspan. And at the same time, as we talked about, as we go to these enterprises, we see the desire for managed services. So the initial thing is that we are going with managed service partners who will bring this to these different enterprises, and they will manage for you on behalf of, depending on your needs, and they will manage multiple sites, locations, they will deploy, operate on a day-to-day basis as well. Okay. Any questions around that? So to quickly delve into some of the components, I know there are different components, complexity, take away that complexity on the private networks, right? So if you look at the orchestrator, a little double click on that. On the top portion is the PMN orchestrator, that's our orchestrating. Then there is the network which controls all of the network elements for the converged core. But at multiple sites, if you see at the PCC, which is at the edge, and site 1, and site could be at different locations, could be in Las Vegas, New York, and could be also global. We can all manage orchestrator for the same enterprise. There are different roles which can be assigned, and we will talk about that access as well at the level, at the partner level, as well as at the operator level. You can manage multiple enterprises from the same administrator. It provides that multi-tenancy, and also the data locality, which we talk about for each of the enterprise. So no sites sees another site's data within the same enterprise. It's up to you to how you want to manage it. And if you want access between devices, and it's on your own networking. We don't place restrictions on the IT changes, what is your each premises to premises. And just sneak peek into what is the orchestrator tool looks like. On the top is the customer configuration. You enable a service. Let's say we have an SD-WAN currently as a solution from VMware or any other solution. You enable a new service, say PMN as a service. You enable you with one of the licenses. And once you're enabled, you can build a new site, access points, and a converged core for that particular site. You have a single dashboard for multiple sites, so you can have a visibility into multiple sites. What are the current deployed sites? What is the status of the network? Yeah.
What do you consider a site? Where the radios are?
Where the radios are.
Where your,
One packet core along with the access points together under one roof is the site. It could be quite possible, let's say, in a multi-floors environment, quite possible there are different enterprises. And this particular site in this geographic location may be one converged core with the sites, maybe something on the other floor could be another site with different access points. That is considered a second site. Yeah. Okay. But all managed to the single orchestrator if it belongs to the same enterprise. And if there are multiple enterprises, the same partner can have visibility to all these enterprises so that they have a single visibility to all the enterprises as well. And they have multiple personas. I'll come to that as well. I'll come to that one. And probably I missed it, but I'll talk about it. The POP is a subscriber database information. It collates all the aggregated subscriber. It's all ensured that there are different subscribers for different enterprises, but they are hosted in our VMware POPs, which are secure. And as part of the, the certification, we ensure that nothing leaves that POPs. It's only for authentication that information is required. Rest of it is only for, security purposes, all walled garden within that POPs. And these are across multiple regions. Say the enterprise one, site one is in Las Vegas. I connect to the closest POP in this region, and that has a guaranteed latency for authentication. If I go to New York, it connects to the closest POP in New York. And if there is a POP which is in Europe, we connect to the closest POP in our Europe. And the same device feels the same user home experience in that each of that network. That enterprise. You seamlessly connect to yours. So you don't have to change SIM cards, you don't have to change anything. It's as plain as from one location to another. We scale as you need. Okay. So to briefly touch upon the dashboard itself, because I think we just not have the visibility for the dashboard, but operations is one part of it, but also the deployment. You can deploy as many sites at different sites locations, have visibility once it's deployed, alarms, events, notifications, all come into the main dashboard, and it's well tightly integrated as part of our roadmap to any IT existing tools where the IT administration may get a notification if there are some severe alarms at particular sites. So it's well integrated with an enterprise first approach. Okay. And I want to talk about one of the key aspects of our orchestration is the multiple personas. So the MSP admin is kind of is doing on a day-to-day basis. He can have different administration privileges where you can add a site, create site, provision the site. You can add radio access depending on how many radios as you scale up. So we have different tiers of access points which you can create. You can do the installation as you need, and at the same time do monitoring and troubleshooting. But for an enterprise, you may just want to prevent some access. So you want to make sure that it's only have visibility to the network. They need to definitely know what is going on in their network, report back, and they may be looking into alarms and events. They may look into some of the KPI and statistics on the performance of the network. So we provide that capability from our orchestrator to have role-based access to each different personas of users. You have multiple users also within this category, within the enterprise admin, and where some of them may have an ability to create one subscriber profile. Hey, I have a SIM card which seems to be much more on a higher priority, I need to change the priority from a best effort to a higher QCI, you can make that change. But you cannot add a user. The user will add through the MSP admin. And the MSP can also have multiple different roles to perform. And on top of it, VMware in the backend fulfills you from the technology enablement, licensing these sites to the MSPs. Whichever the SKUs are purchased, we'll let you know, use that particular site to be provisioned for that enterprise as well. In the backend, we'll enable you from whatever the way you want to consume it. Okay. One of the key things, I think this was one of the innovations which we have done with Airspan. We want to bring it out. Everyone thinks about RAN is one of the critical component which brings complexity to the network. We want to make it as simple as plugging it, powering it on, and connecting like an Ethernet cable. With the help of innovation from Airspan and from our orchestration tool, it's been a lot of work which has gone into this, which is a unique proposition from our side. And that's what it's zero touch, very plug and play environment from Airspan. At the same time, we abstract their element management system so that you can have a single element management system from our side. And then it can do the same exact thing of provisioning, orchestrating, and a day-to-day management from our own orchestrator tool. So all these are some of the key things of barriers which everybody has, and we want to take that away. RAN, there are a lot of templates which ensures that, we talked about the lot of timing, synchronization, power. These brings a lot of value add compared to Wi-Fi, and that requires some complexity, but we have templatized that and ensure that this could be done seamlessly in terms of bring up. So we just do a very basic configuration of the serial number on the PMNO. You power on the AP, the IP just addresses provisioned through assigned to the access point automatically through the DHCP server. It auto calls home, so there is no firewall required to be opened up from the enterprise. It does a call home feature to our PMN orchestrator. And through that orchestrator, we say, okay, we authorize based on the serial number which has been provisioned for that access point, and it auto pushes the configuration very specific for that access point. And once that is done, we'll push all the RAN templates which is unique for that access point, very unique to that access point, to that location. All seamlessly through their element managements, all the different templates which you see is all pushed seamlessly into that network through the enterprise. And AP is in service in minutes. And this is in a service which been seen to be impossible in the past, has been able to do that. So you see a private network, multiple access points deployed, this could be done in a few minutes. Okay. So what are the key takeaways, right? So I think obviously there are different components, different pillars we talk about, and connectivity is one of the key options where we want new services, we want to connect devices, we want to bring in RAN components to it on top of it so that we have assured, guaranteed service, guaranteed each device capability with certain quality of service on demand and at a definite throughput. All the different components of the network for a private network could be bundled together. We provide that as a service to our MSP partner, and the MSP partner takes it to the enterprise. And as I said, managed on a day-to-day basis from level 1 support to level 2 support by our partners, and in the back end, we take care of all the automation and LCM in the back end for level 3 and 4 to the enterprise, to the managed service provider. And if you look at some of the private networks deployment, this is one of the key requirements as a key barriers which we move ahead, that the private networks will be easy to use and removing that complexity. Okay. A lot, but to see in action is believing it. And we have it in our booth. In some of you have already visited, live in action, a future of retail for smart retail, an instantaneous, pick up from the inventory shelf. You see the detection all over the wireless network and inferencing done at itself, all done at the edge. So visit the demo hall. And if you have any Q&A, I'm happy to take questions along with Kyle.
So you mentioned Airspan as one of the partners.
Yes.
Mostly against you, Kyle, but let's say I get mad at this gentleman and want to use somebody else's.
Yeah. It would never happen.
So I could switch
Yeah.
AP and another.
Yeah, I think one of the key reasons being going with Airspan, right? I think in the ability, the agility, what the enterprise require, and the ability to bring in these features. I mean, we have really mandated some of these features, and they have come up within it's not days, but months. As we compare to the other vendors, it takes years to get something on their agenda. And they are very geared toward private networks. Similarly, I mean, there are several others who have been in the space as well. So quite possible, and I mean, it's an enterprise desire, and our focus is still enterprise first approach. It has to be simple, plug and play operations, make it simple so that the end customer is not waiting on something to be deployed just because of RAN, right? That is the key consideration. As Kyle did mention, that it's carrier grade, all the features what you require. It supports both 4G and 5G. Our core supports both dual stack 4G and 5G, and they have the same form factors for both 4G and 5G, indoor and outdoor. And I mean, Kyle, you can anything to add on top?
No, I mean, we're a member of the Open RAN Forum, so we're a believer in that open technology. I think what we have done that's a little bit unique is take that Open RAN stack and put it on one device. So from a hardware perspective, it looks more like a traditional 4G small cell because that's just easier to use. When you take Open RAN into enterprise, it's really challenging. So we've tried to make it very easy.
So the MSP would take care of the firmware update of the radios as well?
So in the backend from the orchestrator, we just know what is the compatible hardware and the radio software. We'll take care of through our LCM management, through our orchestration, completely done by us. So you know the radio hardware, we just push the software as when the enterprise wants to make that update. It's up to you, and it's up to the MSP when they want to make the update. We make it seamless.
So orchestrator provide the network services like these?
Yeah, so from the DHCP, the enterprise, so we don't want to place any placement of networking part of it. It's completely enterprise to enterprise. We take care of it in our backend system so that we can provision from a provisioning point of view. Devices, obviously, whatever is the devices, IP address, you tell us that, we use that IP addressing schema. It's completely transparent on that one.
You support other bands than CRS, band 41, EBS spectrum?
Yeah.
Yes, we do. So it's a different radio model. It's not all in the same radio, but we have a variety of LTE bands. And then more importantly, as we head into 5G, we cover the full C-band. So we have for example, a 3.7 to 4.2 gigahertz model, which is particularly useful in Europe, but also there's some private spectrum in the US. So that'd be N77. We're working on an N41 model. It's not out yet. Right now, we've just covered C-band. So from 3 gigahertz all the way up to 4.2, inclusive of CBRS. And that covers most of the world, actually, from a shared spectrum access perspective. 3.0 gigahertz. Not yet, but that one's in the works.
So how do you control the handoff from private networks to, say, a Verizon network that's running on your access points?
Yeah, it's a good question.
Yeah. So in terms of private, I mean, obviously the indoor and outdoor coverage, if you're looking from a roaming perspective, at this moment on our current initial availability, we have the private networks. We don't have the roaming between private network to go to the micro. So it's the next release where we are working on, and it involves the backend system from our core to connect to the roaming. So partner agreements in terms of if the enterprise desire that there are certain use cases, obviously like a hospital use case. Is there something coming in from patients to be brought in inside and going out? So we want to make sure that it's seamless. It's a critical use case. So we are looking into that. It involves not the technology enablement, it's more on the business aspect of it. We have the technical levers in place. It's a matter of enabling. It's still 3GPP. You just connect to that core, do the home to visitor PNMN. And so,
assuming that all gets done,
yeah.
you would still be able to specify the private network as the priority.
Correct. So you'll have a prioritization of that on the private network PLMN when you're in the network, and as soon as you hop on, you go to the PLMN of the public network. Yes, 2 questions. Yeah, go ahead. Go ahead. No, go ahead.
So for the Airspan stuff, where does the APC run? The NMS, APC?
ACP?
So it's all abstracted by the VMware system, right? So the EPC is the core, and that is on the edge compute and part of the VMware orchestration system, right? So we have an OSS that somebody like a carrier like AT&T would use, but that's abstracted by the orchestrator. So all you see is the orchestrator from VMware. You get the core, you get the interfaces into the OSS to control the entire network, but you never have to deal with the Airspan OSS directly.
So the SIM is all handled through our orchestrator, completely through us. The subscriber information is all. The physical SIM is managed by the service provider, the MSP, the managed service partner from our side, whereas the subscriber information for these enterprises is all done through our orchestrator too.
So who's your managed service provider?
So there we have 3 announced in part of our announcement yesterday. There is Boingo Wireless, Betacom, and Federated Wireless. These are our first partners, MSP partners.
SaaS is built into that as well?
So the SaaS is, the MSP will have their own SaaS so that they have their own choice. Federated, for example, right, wireless, they will have their own choice of SaaS and it connects to the same ACP in the backend. So they can have their own credential and they will package that together to the enterprise.
So it all goes back to the domain proxy?
Yeah,
Yes.
so the domain proxy and then the domain proxy talks to the SaaS.
Yeah, our system actually hosts the domain proxy, right?
they
So
have
we
their own
take care
domain
of that
proxy.
domain proxy heartbeat to the SaaS, but that's all set up and configured one time by the managed service provider. And then from an enterprise perspective, it's not something you need to manage on a day-to-day basis. That SaaS coordination goes on.
No,
All
no
good.
worries. Good questions, keep coming. Yeah.
What are the fees involved for, like, potentially roaming, if there is roaming?
Yeah. I'm sure, I think as part of the initial availability, we are working with our MSP partners. And they are in a phase where we are working on the pricing model for this one. And the partner, in turn, will work with the enterprise from the pricing perspective. So we go to the partner, and that pricing will be coming from the partner themselves. Yeah.
So the partner is the provider of the hardware?
Only the hardware, just the RAN hardware for this point of time. And the spectrum, if it's necessary for you, if you desire a PAL spectrum. Otherwise, it's just the hardware from Airspan. VMware does not do hardware.
Who do we buy it from?
Partner, MSP. This is the MSP. MSP is the
You
front.
buy everything from the partner, and the partner buys the hardware from us, deploys it for you, and then coordinates it with their system. And then what
all
you're
the-
left with is the view of the orchestrator to use.
Yeah.
So we already have a heavily deployed network, primarily by cells, these and stuff. Is that something that you would be willing to integrate into?
So that's a different radio vendor, right? So we need to do all this work, as I mentioned, right? There's a lot of complexities to make it easy to happen. If you want to grow in scale, if you want to grow it into enterprise, we think that we need to ensure that for an enterprise-centric, we have to have this tight integration in our network, and that's what we have done. So we may have to look at it a case-by-case basis, the different RAN vendors of choice, which has been done. But at the moment, we have only Airspan. Yeah. And obviously that we will evaluate as we go. It's your question, sorry.
DoD, have you partnered with DoD? Are you deploying for the DoD today? How big?
Yeah, so as I said, we have to go through the MSP partners. We don't go to enterprise direct in this part. For the partners, definitely there is a lot of certification involved, so depending on that partner, nothing restricts us from us to provide this solution to the DoDs of any, for consuming this. But obviously there are some certifications which are necessary as part of the overall solution and the right partner to go with. So there are some tiering, so we have definitely have conversations. Our enterprise segments do talk to some of these DoDs and from a certification perspective and the right partner to bring it in because they need to be certified at certain levels. So of those choice, then they can select who is that MSP partner I talked about. So, and they select that MSP partners and they can bring the solution to them.
And from a radio perspective, we have
Radio
a lot of trials going on
Yes.
with DoD and solutions in a number of different of the segments.
Yes.
This may be an MSP question, but what's the deployment process like? You know, the actual spin of time, you know, how quickly, like in my business, I can have a site that's up for 7 months, I can have another site that's a year and a half, you know.
Yeah.
Pull down, have to move to another location, what's the deployment process like?
Okay, so I envision something, at least from our side, with our understanding. MSP partners, which we have selected, they are been deploying these private networks and some other Wi-Fi in the past. They are experts in some of these deployments. So definitely there's a lot of expertise in that end as well. It involves RF site survey in that location, ensuring that you're the the right location with the right access points coverage wise. So that's definitely a I would say prerequisite as part of this exercise. Where do you want it? It's one part of it. And then need to ensure that what is the the subscriber information, what are the number of subscribers. So we do some dimensioning along with them once that has been ascertained from the initial site survey. And that, I think we can make a call depending on that. But as far as provisioning, it's very simple. I think we have made that simple for that partners, so they can do it repeatable, they can go to multiple sites, as easy, as simple, and deployed. Yeah.
Between those three, I think you guys have a very broad span of coverage throughout the U.S. or how between those three USP, are they everywhere? Are they only in certain markets?
No, it's I won't be able to tell like exactly where that it's dependent on the enterprise. So the route to markets is dependent on the ours. It's a combined effort from our side as well. So we have entrance into a lot of different enterprises. There is a need from that. We bring in the partner of choice because we need to ensure that the partner has either some legacy work done with them or they may be new, they have a choice. So we work with them accordingly. So it's not a preferential location-wise or what they have done.
All three of those managed service providers are nationwide. They
They
tend
are
to focus on specific segments. They each have their segment, like vertical, that they focus on more than another vertical, but it's not geographic.
So Boingo, for example, so they are very much present in a lot of the stadiums, airports. You might have seen Boingo Wireless, so that would be an easy fit if there is a private network. Specifically, that's the by choice, I would say, really. But it's all driven by other factors as well. Yeah.
What are the requirements for the network perspective to those radio? I understand probably BTP or GPS.
Yep, yeah, three things. Power, a form of synchronization, and then the backhaul or front haul in the case of O-RAN. Power is simple enough. Sync is the most complicated. Generally, you can do that through GPS, but you usually can't get GPS indoors. So typically what would happen is one GPS run to the roof to something that comes into something called a 1588 server, Grandmaster server, and that distributes the timing over the IP network to the radios. So you don't have to bring GPS to every radio, you bring it in once. The third one is the backhaul, and you basically just need the amount of IP throughput on your LAN that you expect to get out of the radio, right?
Those are what 1 gig interfaces?
1 gig, and the 5G has 10 gig. Both fiber and copper.
Okay. Thank you, everyone. Sorry to cut you short. I think there's the next session coming in, but really appreciate it for taking the time. And do take a survey. And if you have some time today or tomorrow, do stop by the booth, live in action in PML.
Thank you.
Okay. Thank you. Thank you very much.